In this video, we are using matrix inverse to solve two linear systems. It's very simple. First, we have to compute matrix inverse, then we will use it to compute the solution for linear system 1 and linear system 2. But they have to be the same coefficients. You noticed here -2, -2, 1 here, 1, -5, -5, 1, 1, here 1, here 1, 3, 3, 1, 1, here 0, here 0, because here you notice that there is nothing here because 0 multiplied by y equals 0. So that's why it disappear y. 3, 3, so they have the same coefficient, but the result vector here it's different than this. So let's read the question. Here in this example, using matrix inverse to solve the two linear systems, linear system 1 and linear system 2. So we want to solve these two linear systems. Before to solve the question, let's read this important here note. Almost every time we put this important note, which is if A inverse exists, then A multiplied by A inverse equal A inverse multiplied by A equal identity. Here, it's like multiply a number by its reciprocal. For example, let's say here this 3 multiplied by here 3 bar -1, which is almost the same as this, but here matrices, but here in this one it's not matrix. Equal, I will swap these two, so 3 bar -1 multiplied by 3 equal the same equal to 1. So here it's the same as here, but here it's a matrix. It's not a number. So here matrix multiplied by its inverse, it's equal to identity matrix. So you should always get identity matrix. So it's matrix, not a number. So here almost the same thing as a number multiplied by number for -1 in the same sense. Now let's delete this one. Now let's solve the example. Since we noticed that the two linear systems have the same coefficients, let's rewrite the two linear system to understand where is the matrix inverse. So here let A equal, so here -2, 1, -5, -2, 1, -5, 1, 1, 3, 1, 1, 3, 1, 0, 3, 1, 0, 3, x, here this one in bold, which represent the solution. Here the solution here x, y, z, x, y, z. Now here the result vector here for the linear system 1, let's call it b. Zero, 1, 1. So 0, 1, 1, which is here, 0, 1, 1. I wrote it here. C, the result vector for the linear system 2, 1, 2, 3. Because they have the same coefficient here, -2, 1, -5, -2, 1, -5, 1, 1, 3, 1, 1, 3, 1, 0, 3, here 1, 0, 3. So you notice that the matrix inverse here, which is the inverse of this A, where the linear system 1 system 1 represents as ax equal b, ax equal b, here a, the coefficient, x, x, y, z, b, 0, 1, 1. So here, this one, it's in bold color, comma, and I have to continue here, but it's better to visualize it here. So, and the linear system 2. Represent as a x here in bold equal c, which is here c. So we rewrite the two linear system like this. Now we have to find the inverse of this a. First we have to write it in augmented form. So a identity with size 3 by 3 means. Let's go a little bit down. Here I have to write a, which is this one. I will write this a, so I will speed it up here. Now I will write the line of the augmented form. Here I will write identity. So here I will write identity with size 3 by 3. So I will speed it up. Now I will close this bracket. Now we want to do RREF to the left side. The left side, I mean the matrix before this line, which is the matrix A. So I have to apply RREF to this side, and the operation that we do to the left side, we have to apply it for the right side as well. So we have to transform this A to identity. However, if we cannot transform this A to identity, for example, if we have a 0 row, then we have to say A inverse does not exist. So it's very simple. We have to transform this A to identity to get A inverse. Now let's change the color. So here we have to put this one 1, then here 0, 0, 0, 1, 0, 0, 0, 1. We have to make it like this, identity. You notice that it's better to swap this row with this row, because here we have to make it 1. So here we have 1 and here we have 0. So this row, it's better to change it with this row, because here we have already 0, not like this one, because if we swap this one with this row, then we have to make this one 0. So it's better to choose this one to swap it with this one. Of course, here you can divide this row by -2 to make this one 1, but it will be a lot of fraction. So think carefully before to solve it, because if you choose carefully what you want to do, it will be easier to solve it. Like here, if you swap this one with this one, then you don't need to make this one 0. But if you swap this row with this row, then you have to make this one 0. So I prefer to choose this one instead of this one. And of course, it's better to not choose this one, because you have to divide it by -2. If you divide by -2, you will get a lot of fraction, then it's harder to solve it. So we want to swap this row with this row. So row 1, swap it with row 3. Since we don't need to do anything with this row, so I'll speed it up to write this row. So I will swap this one with this one. So here 1, 0, 3, 1, 0, 3, 0, 0, 1, 0, 0, 1, and here -2, 1, -5, 1, 0, 0. I will change the color. So now here I have to make this one 0. So because I will make it identity, so here it should be 1, then 0, then 0. So 1 minus 1, you will get here 0. So row 2 minus row 1 in row 2. -2, it should be plus 2. So here, this element we have to multiply by 2. And we have to add it with -2. So -2 plus 2. So here we have to multiply by 2. So row 3 plus 2 multiplied by row 1 in row 3. So row 1, it remains the same. So I will speed it up to write this row first. So here, row 2 minus row 1. So 1 minus 1, which is 0. 1 minus 0, which is 1. 3 minus 3, which is 0. 0 minus 0, which is 0. 1 minus 0, which is 1. 0 minus 1, which is -1. Here, row 3 plus 2 multiplied by row 1. So -2 plus 2 multiplied by 1. So -2 plus 2 multiplied by 1. -2 plus 2 multiplied by 1, which is 2. -2 plus 2 equals 0. So here I have to write 0. 1 plus 1 plus 2 multiplied by row 1, which is here 0. 1 plus 2 multiplied by 0, which is 0. So 1 plus 0, which is 1. So here I have to write 1. -5 plus 2 multiplied by row 1, which is 3. -5 plus 2 multiplied by 3, which is 6. -5 plus 6 equal 1. So here I have to write 1. 1. 1 plus 2 multiplied by 0, which is 1. 0 plus 2 multiplied by 0, which is 0. 0 plus 2 multiplied by 1, which is 0 plus 2 multiplied by 1, which is 2. 0 plus 2 equal 2. So here I have to write 2. Let's change the color. Now, here we have 1, here we have 1. So here we have to make this one 0. Because we start from here, we make this one 1. Then here we have make these two 0, like here. Now we have to make this one 0, because the rest of this column has to be 0. So here it has to be 0. So 1 minus 1 equals 0. So row 3 minus row 2. So row 3 minus here row 3 minus row 2 in row 3. This row and this row to remain the same, so I speed it up to write this row and this row. Zero, here row 3 minus row 2, so 0 minus 0, which is 0. So here I have to write 0, 1 minus 1, which is 0, 1 minus 0, which is 1, 1 minus 0, which is 1, 0 minus 1, which is negative 1, 2 minus negative 1, so 2 minus negative 1, which is 2. Negative with negative, it will be positive 1. So the answer it will be 2 plus 1, which is 3. So here I have to write 3. 3. Now here leading 1, here leading 1, here leading 1. So we have to make the rest of this column 0. So here this one it has to be 0. So it should be 3 minus 3 equals 0. So here we have to multiply this row by 3. Then we have to say 3 minus 3. So row 1, because we want to change row 1, minus, because 3 minus 3 here. We have to multiply this, the third row by 3 in row 1. Since we don't want to change this row and this row, the second row and the third row, therefore I will speed it up to write these two rows. Row 1 minus 3 multiplied by row 3. Let's go down a little bit. So 1 minus 3 multiplied by 0, 3 multiplied by 0, which is 1 minus 3 multiplied by 0, which is 0, 1 minus 0, which is 1. So here I have to write 1. So here 1, because 1 minus 3 multiplied by 0, which is 0, so 1 minus 0, which is 1. The same thing here, 0 minus 3 multiplied by 0, which is 0, so it will be 0 minus 0, it will be 0. Here 3 minus 3 multiplied by 1, 3 minus 3 multiplied by 1, so it will be 3 minus 3 multiplied by 1, which is 3, 3 minus 3, which is 0, so here I have to write 0, 0. Now here 0 minus 3 multiplied by 1, 0, minus 3 multiplied by 1, so 0 minus 3, because 3 multiplied by 1, which is 3, 0 minus 3, which is negative 3. So here I have to write negative 3. Zero minus 3 multiplied by negative 1, so 0 minus 3 multiplied by negative 1, it will be 0 minus with minus here, it will be positive. 3 multiplied by 1, which is 3. 0 plus 3, which is 3. So here I have to write 3. One minus 3 multiplied by 3. So 1 minus 3 multiplied by 3, which is 9. 1 minus 9, which is negative 8. So here I have to write negative 8. Negative 8. as you can see here, we have here leading one, here we have leading one, here we have leading one. So this here, it's identity with 3 here, it's mean 3 by 3, and here it will be A inverse. So we have start from here A, and here identity with side 3, we end up with A inverse. So this equal identity 3, which is here 3 by 3, the line of augmented, then here A inverse. Therefore, this is the symbol of therefore, A inverse exists, and A inverse equal to this one. So here I will speed it up to write this A inverse. So A inverse, which is this one, negative 3, 3, negative 8, 0, 1, negative 1, 1, negative 1, 3. So we have computed A inverse. Now let's go a little bit down. Let's change the color. For the linear system, one, the linear system 1 here, which represent as we assume that here A, which is this one, x equal this one, b equal this one. So I have to write ax equal b for the linear system 1. So I write ax equal b. So here, since ax equal b, then we can multiply by A inverse in both sides from the left because A inverse exists. So from the left we multiply by A inverse. And you can see here this one here, which can be symbol to identity. So here this side it will be identity with size 3 because here A is 3 by 3, and here x A inverse multiplied by b. And we know that any matrix multiplied by identity matrix, it will remain the same, so it will not affect anything. So to simplify this one, it will be just x. So therefore x equal A inverse multiplied by b, because identity it will disappear. Let's change the color. So for the linear system 1, x equal A inverse multiplied by b. Therefore x equal A inverse multiplied by b equal A inverse, which is here. I will copy it to put it here. And here b, where is b? Let's go up. So b, which is 0, 1, 1, the linear system 1, 0, 1, 1, which I wrote it here, 0, 1, 1, 0, 1, 1. Now let's multiply this matrix by this vector. So let's change the color. So this one is 3 by 3, and this vector is 3 by 1. So the result here, it will be 3, 1. So 3 row and 1 column. So this one is 3 by 1. To find this element, we have to multiply this row by this column. So -3 multiplied by 0, which is 0, plus 3 multiplied by 1, which is 3, plus -8 multiplied by 1, which is -8, equal 0 plus 3, which is 3, positive with negative, it will be -8, 3 minus 8, which is -5. So here I have to write -5, -5. To find this element here, we have to multiply this row by this column. So 0 multiplied by 0, which is 0, plus 1 multiplied by 1, which is 1, plus -1 multiplied by 1, which is -1, 0 plus 1, which is 1, positive with negative, it will be -1, 1 minus 1, which is 0. So here I have to write 0, 0. To find this element here, we have to multiply this row by this column. 1 multiplied by 0, which is 0, plus -1 multiplied by 1, which is -1, plus 3 multiplied by 1, which is 3, 0 plus -1, which is -1, plus 3, -1 plus 3, which is 2. So here I have to write 2, 2. So that's it here. We find this x. Therefore, the linear system one, the linear system 1 has a unique solution x in bold, this one, because it's the vector of the solution, x, y, z, as we wrote it here, x equal xyz equal -5, 0, 2. Now for the linear system 2, since we have here for the linear system 2, which is this one, as ax equals c, so here this c, 1, 2, 3, so I have to write ax equals c, which we will write the same way as we did for the linear system 1. So since ax equals c, as we did, then since A inverse exists, as we wrote it here, so you multiply by A inverse from the left for this equation. A inverse multiplied by AX equal A inverse multiplied by C. And the same as we did here, this with this, it will simplify by identity. Therefore, here, then, it will be here identity with size 3 by 3, X, and here it has to be in bold. The same thing here, it has to be in bold, because as we did here, X here in bold, X, Y, Z, it represents the solution, equal, we will write it as here, so A inverse multiplied by C because this simplified to identity. This side, it remained the same. Then, and this one, it's simplified to be just to be x. A inverse multiplied by C. Therefore, x equal A inverse multiplied by C. And we know A inverse is this one. I will copy it. And C, which is up here, 1, 2, 3. We call this vector C, 1, 2, 3, and we call this the linear system 2 as AX equals C. So C, 1, 2, 3. This C equal 1, 2, 3 equal. As we did here, we will do the same thing. We have to multiply these to get the solution, which is x. So this to represent as like this. To get this element, we have to multiply this row by this column. -3 multiplied by 1, which is -3, plus 3 multiplied by 2, which is 6, plus -8 multiplied by 3, which is -24, equal -3 plus 6, which is 3, positive with negative, negative, and here it will be 24, 3 minus 24, which is -21. So here I have to write -21. -21. To get this element here, we have to multiply this row by this column. 0 multiplied by 1, which is 0, plus 1 multiplied by 2, which is 2, plus -1 multiplied by 3, which is -3. So here it will be 0 plus 2, which is 2. Positive with negative, it will be -3. 2 minus 3, which is -1. So here I have to write -1. To get this element, we have to multiply this row by this column. 1 multiplied by 1, which is 1, plus -1 multiplied by 2, which is -2, plus 3 multiplied by 3, which is 9, equal 1 plus 9, which is 10. Positive with negative, it will be -2. 10 minus 2, which is 8. So here I have to write 8. 8. Therefore, I write the same way as we did here. The linear system two has a unique solution, which is x in bold here equal this vector x, y, and z equal -21, -1, 8. So the solution for the linear system 2 has a unique solution, which is -21, -1, 8. So if we substitute x equal negative 21, y equal negative 1, z equal 8, we will get the solution. So if we substitute those here, so if we substitute x equal negative 21, y equal negative 1, z equal 8, we will get equal 1. And the same thing, if we substitute these number, we will get here 2. The same thing if we substitute, we will get 3. The same thing for the linear system 1, negative 5, 0, 2. So if we substitute here negative 5 and here 0, and for z equal 2, you will get 1. So you can check this if you want to make sure that your answer is correct. As you can see, using matrix inverse is very beneficial to solve these two linear systems, because we have just to compute A inverse, then we have to multiply A inverse multiply by this vector, we will get the solution. And the same thing here, we have to multiply the inverse of this one and multiply by the result vector, we will get the solution. So you can see here, A inverse multiplied by B, we will get the solution. And here, A inverse multiplied by C, we will get the solution. So it's very beneficial if we have more than this linear system. And of course, if we have 5 by 5 or 6 by 6 matrix here, it's very beneficial to find the inverse of a matrix to solve these linear systems that they have the same coefficient. The same coefficient, I mean here, negative 2, 1, negative 5, negative 2, 1, negative 5, and the same thing here, this side the same as this side is the same as this side. That's it. In the future video, we'll do more examples about the matrix inverse and its properties. So we will go deep about the matrix inverse and to understand the most important properties which we have to know. Feel free to comment below if you have any question or suggestion about this video. See you in the next video.